Hi everyone, in this video I will be discussing about the ellipse. But before I proceed, I would just like to give credits to Lumen Learning for the content of this discussion. So for our objectives, by the end of this section or this topic, you will be able to first write equations of ellipse in standard form, graph ellipses both centered at the origin and also ellipses that are not in the origin. And lastly, solve applied problems involving ellipses. So those are our objectives. So here we have an illustration of the National Statuary Hall in Washington, D.C. This building somehow has a connection regarding our topic. So, can you imagine standing at one end of a large room and still be able to hear a whisper from a person standing at the other end? The National Statuary Hall in Washington, D.C., this one, that certain hall, is such a room wherein we can do so. It is an oval-shaped room called a whispering chamber because the shape makes it possible for sound to travel along the walls. So in this section, we will investigate the shape of this room and real-world applications, including how far apart two people in the statuary hall can stand and still hear each other whisper. So isn't that amazing? So we now proceed to writing equations of ellipses in standard form. And at this point, let's try to recall the definition of a conic or a conic section, which we have discussed before. So a conic or a conic section or a conic is a shape resulting from intersecting a right circular cone with a plane. So the angle at which the plane intersects the cone determines the shape. So I think you're already familiar with the last part, the last conic section, since we were done discussing that one. So that is a parabola. This one right here, wherein the plane intersects the upper and the lower cone, that is a hyperbola. And our focus for this video will be this conic section right here, which is the ellipse. So conic sections can also be described by a set of points in the coordinate plane. So later in this chapter, we will see that the graph of any quadratic equation in two variables is a conic section. The signs of the equations and the coefficients of the variable terms determine the shape. So this section focuses on the four variations of the standard form of the equation for the ellipse. So take note, there are four different variations or four different types of the standard form of the equation of the ellipse, depending on its location on our graph and depending on its orientation, whether it is horizontal or vertical. So this section focuses on the, so let's go ahead with the definition, the formal definition for the ellipse. So take note of that. So an ellipse is the set of all points xy, ordered pair xy in a plane, such that the sum of the distances from two fixed points is a constant. So each fixed point is called a focus, and since there are two, the plural form for focus is called the foci. So manually, we can actually draw an ellipse using a piece of cardboard. So if you have two thumbtacks, you have one right here, the other right there, a pencil and a string. So you place the two thumbtacks in the cardboard to form the foci of the ellipse. So one foci here, the other foci there. Then you cut a piece of string longer than the distance between the two thumbtacks. So make sure that the string is longer than the distance between the two thumbtacks. That is the length of the string represents the constant in the definition. So after that, you take each end of the string to the cardboard and then trace a curve with a pencil held taut against the string. So if you have the two thumbtacks right here, then you place the ends of the string of thumbtacks. You can actually draw the ellipse using the string and the pencil. So your drawing, manual drawing of the ellipse. If you have again the thumbtacks right there, you have the string there, you can draw the pencil around and you will be able to draw and form the ellipse. Actually, you can also draw a perfect circle. So if you have a thumbtacks and a string, only one string, then using the pencil, you can actually trace the circle using a thumbtacks and a string. So we now proceed to the different parts of the ellipse. So every ellipse has two axes of symmetry. If you can still recall with our discussion on the parabola, the parabola only has one axis of symmetry. And if you can still remember axis of symmetry, that's the line that divides the parabola into two equal parts. So same with the ellipse, but this time we have two axes of symmetry. The longer axis is called the major axis and the shorter axis is called the minor axis. So the endpoints, each endpoint of the major axis is the vertex here. So the major axis, the endpoints, one vertex right here, the other vertex right there, and since there are two, the plural for vertex is vertices. And each endpoint of the minor axis is a co-vertex of the ellipse. So if we have a horizontal major axis, the endpoints are called the vertices. And if we have a vertical minor axis, the endpoints of that are called co-vertices. Now the center of an ellipse is the midpoint of both the major and the minor axis. So if we have a horizontal major axis and a vertical minor axis, their meeting point, or the point wherein the two axes will intersect, is called the center of the ellipse. And the axes are perpendicular at the center. Perpendicular meaning they will form a 90-degree angle. Now the foci, so the fixed points, the two fixed points, the foci, always lie on the major axis. So if your ellipse is horizontal, the foci are on the major axis, yeah. And if your ellipse is also vertical, so the foci are also, or can be located on the major axis. So the sum of the distances from the foci to any point on the ellipse, the constant sum, is greater than the distance between the foci. Now let's take a look at this illustration. So this is an illustration of an ellipse wherein its orientation is horizontal. So again, we have different types of ellipse depending on its orientation. So here, this is horizontal in nature. This part right here, that's the center of the ellipse. Now, since our ellipse is horizontal, our major axis is also horizontal, and our minor axis is vertical. So that's the minor axis. So here we have our foci, f sub 1, then f sub 2, then the endpoint for our major axis, we have one vertex right here, another vertex right here, and the endpoints for our minor axis, we have a co-vertex here and another co-vertex there. So notice that the two axes, the major and the minor, they intersect at the center, and these are perpendicular. It forms a 90-degree angle. Now in this section, we restrict ellipses to those that are positioned vertically and horizontally in the coordinate plane. So again, in this discussion, we will only be focusing on four types of ellipse depending on the location on the graph, may it be at the center or not, and may it be horizontal or vertical. That is, the axis will either lie on the parallel to the x, so parallel to the x and parallel to the y. Later in the chapter, we will see ellipses that are rotated in the coordinate plane. So there are ellipses actually that are not just horizontal or vertical, but it can be rotated in our Cartesian plane. So to work with horizontal and vertical ellipses in the coordinate plane, we consider two cases, those that are centered on the origin and those that are centered at the point other than the origin. So if our ellipse is at the origin, we know that the coordinates of the center are 0, 0. But if our ellipse is not at the origin, the center will be represented by HK, which I will be discussing later. So first we will derive the equation of the ellipse, and then we will learn how to write the equations of ellipses in standard form. We need not derive actually the equation. Let's just take a look at the standard form. So again, for the purpose of this discussion, I will not let you derive the standard form of the equation, but here it is. So thus, the standard equation of an ellipse, take note of this one, that's x squared over a squared plus y squared over b squared is equal to 1. So this equation defines an ellipse centered at the origin. So if a is greater than b, a right here and b right here, the ellipse is stretched further in the horizontal direction, and if b is greater than a, the ellipse is stretched further in the vertical direction. So if you will take a look at the equation, if you see that a is greater than b, meaning your ellipse is horizontal. But if you see that b is greater than your a, meaning the ellipse, the orientation is vertical. We now proceed in writing equations of ellipses centered at the origin in standard form. So standard forms of equations tell us about the key features of graphs. So take a moment to recall some of the standard forms of equations we've worked in the past. So there are different types of equations: polynomial equations, linear if the highest degree is 1, quadratic if the highest degree or exponent is 2, cubic, exponential, logarithmic, and so on. So by learning to interpret standard form of equations, we are bridging the relationship between algebraic and geometric representations of mathematical phenomena. So for ellipse, the key features of ellipse are its center. Take note, these are the important parts which we will also be needing in graphing. The center, the vertices, the endpoints of your major axis, the co-vertices, the endpoints of the minor axis, the foci, the two fixed points, the lengths and positions of the major and the minor axis. So just as with other equations before, like the circle, the parabola, we can identify all of these features just by looking at the standard form of the equation. So there are 4 variations of the standard form of the ellipse. These variations are categorized first by the location of the center. So again, the ellipse can be located at the center, or it can also be in another point in our Cartesian plane. So origin, again, the center is at 0, 0. If it's not at the origin, the center is HK. And then by the position, so there are ellipses that are horizontal and vertical. So each is presented along with the description of how the parts of the equation relate to the graph. So interpreting these parts allow us to form a mental picture of the ellipse. So general note, standard forms of the equation of an ellipse with center 0, 0. So these are the two types of equations of the ellipse wherein the center is at the origin. So the standard form of the equation of an ellipse with center 0, 0 and major axis on the x-axis is this equation. X squared over a squared plus y squared over b squared is equal to 1. So that equation is the equation that we will use if the ellipse is at the origin and if its orientation is horizontal. Again, center is at the origin and the orientation is horizontal. So where A is greater than B, so again, if A is greater than B, our ellipse is horizontal. The length of the major axis is 2A. So since it's horizontal, going to the right, that's A units. Going to the left, that's A units. So if we add that all up, that will result to 2A. The coordinates of the vertices are positive, negative A, and 0. The y-coordinate is 0 because the points are on the x-axis. So going to the right, that's plus positive A. Going to the left, it's negative A since it's the negative side of the x-axis. The length of the minor axis is 2B. So going up, that's B units. Going down, and that's B units. And if we add that all up, again, that's 2B. So the coordinates of the co-vertices are 0, positive, negative, B. The x-coordinate is 0 because the points lie on the y-axis. Positive B going up, since those are positive integers. Negative B going down. The coordinates of the foci are positive, negative C, 0 because it lies on the x-axis, where c squared is equal to a squared minus b squared. So that's the equation that we can use in order to determine our foci. Next, we have here the standard form of the equation of an ellipse with center 0, 0 and the major axis is on the y-axis. So earlier, the orientation was horizontal. This time, the orientation is vertical. So, if you take a look at the equation, look at the difference. So earlier, A was below X. This time, A is below Y squared. So that's an indication. So if A is below the X variable, meaning the ellipse is horizontal. If A is below or over the Y variable, it's a vertical ellipse. So same with earlier, A is greater than B, the length of the major axis is 2A, the coordinates of the vertices are 0, positive, negative A. So this time, the x-coordinate is 0 because the major axis now is on the y-axis. The length of the minor axis is still 2B, but the coordinates of the co-vertices are positive, negative, b, 0, since this time our minor axis is at the x-axis. The coordinates of the foci are 0, positive, negative, c. But still, we use the same formula in order to determine the foci. So c squared is equal to a squared minus b squared. Take note that the vertices, co-vertices, and foci are related by the equation c squared is equal to a squared minus b squared when we are given the coordinates of the foci and vertices of an ellipse. We can use this relationship to find the equation of the ellipse in standard form. Now let's take a look at these diagrams. The first one, this is So again, by the way, the centers of these ellipses are on the origin. So we know that if the center is at the origin, the coordinates are, of course, 0, 0. The first one, this is a horizontal ellipse, wherein the equation is x squared over a squared plus y squared over b squared is equal to 1. So we have here the foci, that's C0, since it's on the positive side of the x-axis, negative C0 because that's on the negative side. We have one vertex there, A0, the other vertex there is negative A0. That's for the major axis. Now for the minor axis, going up, that's 0B, since that's positive. Going down, that's 0, negative b. Now for the second diagram, that's the ellipse, the vertical ellipse with the equation x squared over b squared plus y squared over a squared is equal to 1. So the only difference is that if the ellipse is horizontal, the major axis is on the x-axis. If the ellipse is vertical, the major axis is on the y-axis. And consequently, if the ellipse is horizontal, the minor axis is vertical, but if the ellipse is vertical, the minor axis is on the x-axis. I hope that's clear, but if ever you have some questions or clarifications, feel free to comment your questions in the comment section below, or you can also send it in our group chat, or you can send me a personal, a private message or a direct message.